So hello everyone that's here. My name is Michael Hatch. I work for the Social Science Computing Facility, and I'm here to present on sort of an introduction to the social sciences computing environment. You can think of it as more of a broadly working with supercomputers, research servers. They go by a lot of different names. And basically what we're going to talk about is kind of a feature that's shared by all of them that's called the command line. And we'll go a little bit more into what that means. For the moment, it looks like most of the people in the audience are Mac users. If you happen to be watching via video or anything and you're on a Windows computer, we have a little bit of setup for you. What we're going to ask is that you download a program called PuTTY. And PuTTY is essentially a tool for connecting to remote computers. And we'll go into more about how that's going to be used a little bit later. And we'll also have some time where I can explain how to download it and such if I'm going too fast for you right now. So I'll talk a little bit more about operating systems in a moment, but long story short. Oh, hey, are you here for the command line presentation? Awesome, come on in.
We just started.
Yeah, so I just started. That's a Windows computer?
What? Sorry?
That's a Windows computer?
Yeah.
Do you have a program on PuTTY called PuTTY on there? Do you know?
No.
Okay. So if you wouldn't mind, we'll have time later if you want to do it as well. But there's a program called PuTTY that if you want to download while I'm watching, or download while you're watching me, that'll help in a little bit, and I'll also have time specifically for that later on. Okay, so essentially so the command line is kind of a universal feature of pretty much any computer that you're going to work on. I can't think of any exceptions to that. But it doesn't always take the same form, and we'll talk about it a little bit. The command line kind of comes in different flavors on different operating systems, which is why the solutions or why the setup is a little bit different between Windows, Mac, and Linux. If you're on a Mac computer, the program is called Terminal. If you're on a Linux computer, honestly, this is probably old hat to you. Just for reference, we're going to be working on the assumption that you're on Ubuntu. So if you're on CentOS or Debian or something else, you may have slightly different commands than the ones that I'm going to give later on. Okay, so what is the command line? The command line is a means of giving instructions directly to a computer. What I'd imagine for most of the people here, I'd imagine that you haven't done a ton of like supercomputing, remote computing, working with servers, whatnot. I'd imagine that's the appeal of this presentation. So generally speaking, you're probably used to using a computer by moving a cursor around, double-clicking on folders, things of that nature. And that sort of interaction with the computer is called using a graphical user interface. I might call it a GUI. And the idea behind a command line is that you kind of subvert the GUI. Instead of double-clicking on a directory, you're going to give an instruction for the computer to directly modify the GUI. Or, excuse me, to directly modify a folder. We're going to see this is often more complicated than working with a GUI, but generally speaking, it's also more flexible and more powerful as well. So for an example, the typical way of working with computers, I hope this is large enough.
It's good.
So let me go back one actually. So you see right now I'm in a folder called SSRDE, and there's a folder in here and whatnot. And so moving around the GUI, moving around the file system through the GUI, you're going to double click on your folder. You know, you see we have a text file, then we have some other folders underneath here. The command line equivalent is going to look something like this. Sorry, I have a couple windows open. So we start out on the desktop like we would normally, and you'll notice that even it says I'm on the desktop, but it doesn't really give me much more information than that. So to actually see the folders that we're working with, we have to run a command called ls, and there will be more on this in a moment. You'll actually have some opportunities to get in and get your hands dirty in a moment. And so you see there's a list of folders and files now when I ran that ls command, and one of those is the SSRDE folder. And so then to move into that SSRDE, to do the equivalent of double-clicking, I run cd, which gets us into SSRDE. There's a really neat function on most command lines. If you start typing and you hit tab, it's called tab completion. It'll try to guess what the rest of your sentence is, or what the rest of the command is, excuse me. And that's extraordinarily useful Saves a lot of time. So I can go into SSRDE. There's another subfolder I know in here called SSCF Michael. And then if I want to go up, I can run cd dot dot dash, or dot dot slash, excuse me. And that moves me one up on the rung of the ladder. If you can see in the yellow, that's kind of how you do the back or the one level up command. So that's basics of moving around in the command line. Next step, creating a folder. So typically,
Oh, question.
yes. Question?
Do we have tree on here?
I'm sorry, is that like a command line utility? We may. I'm not working under the assumption that it's there.
Okay.
But as we'll discuss, there are tons and tons of really useful command line tools. And so if you're aware of something like tree that enhances your experience, by all means use it and use this as an opportunity to kind of play around with it and see how tree makes your experience more efficient than using my method, if that makes sense. Cool. Okay. So the next sort of thing that is common to do with files and whatnot, creating new folders, that's pretty easy. I'm working on a Mac environment, but this will look very similar on Windows. You'll do something like right click and then you'll see a new folder option. And then I'm just going to call it stuff. The equivalent on a command line is the mkdir command. And then I give it, so I say mkdir and then I give it the name of the directory. I'm going to call it stuff2. And so we do an ls, we see, oh, whoops, sorry. I'm one directory up, so mkdir stuff2. Okay. And so now we see both the directory that I made with the GUI stuff and then the directory I made with the command line stuff2. So far it looks like this is kind of more work than it's worth. And it's going to start changing when we get into a few more complex tasks. So for one example that I'm going to use, finding and replacing data. So we have a text file here, and we're going to refer back to this text file many, many times. I Love A Tale of Two Cities, great book. Don't spoil it for yourself if you haven't read it yet. Maybe use another text file and then read it on your own because it's awesome. But so let's say that I have this text file, in this case Tale of Two Cities, and let's say I want to do like a find and replace. I want to modify the text and I want to see how that changes things. So what I could do is I can go through and I can replace the word tail with the other form of the word tail, or I don't know, head, we'll just say. So if I want to find and replace on this, I can go through and I can do that every single time manually. If I'm lucky, and in this text editing program, I know I am, there's a find and replace function. But if I've got to run 12 find and replaces, or if there's a complex pattern that I want to, find and replace, or if I'm not sure precisely what I want to use, if I want to have some other file give me the pattern that I'm going to end up finding and replacing, this means of working within the GUI isn't super efficient. If I go through the command line though, we'll see here, I can run a particular command, and we'll notice, so the claim, if this works correctly and if the command line is doing what it's all cracked up to do, the claim is that, and we'll go into this precise command a little bit more later, the claim is that the word tail is going to get replaced with the word story, case sensitive, so keep that in mind. And then we're going to look here, okay, wait, hold on, sorry. Oh, yeah, gotcha. And if we go down here, we see, sorry, this is a bug. Bugs are going to become familiar, but take my word for it, we'll see later on. There are commands that will run through and that will change every version of that, every instance of that text file and whatnot. And that ends up being incredibly, incredibly efficient versus using the command line. Okay, so going back to theory a little bit, how, when, and why is this sort of thing useful? As a practical matter, leaving aside the pluses and minuses of the different methods on their own merit, a lot of the times you're not even going to have an option. So when you think of supercomputers or servers, Many times these sorts of computers, either they're in a data center like the UCSD Supercomputer Center, or otherwise they're not directly accessible. And usually what that means is you don't have a display. If you don't have a display, you don't have a GUI, which means that the command line is usually the only way to interact with these kinds of computers. So often it's just a matter of practical necessity that you have to use the command line. It can also be very flexible. So like we should have seen with the find and replace method that I did, you can give relatively complex patterns relatively easily to computers and have them execute commands. And often this is much quicker and much more efficient than doing things manually through the GUI. Streamlining, same sort of thing. If you're giving the computer a pattern that's been crafted with a clever command line command, hours of manual work can be done in seconds. And then also automation. So if you imagine you have 15 tasks that you have to do, there's a list of I need to find and replace this, I need to rename the file, I need to import it in here, all of that. You can create what are called scripts, which are basically just lists of commands that get executed in order. And these scripts can automate your workflow and you just run them and walk away, which is extraordinarily useful, especially if you're doing really sophisticated analyses. So I said it a little bit earlier, a note on operating systems. The command line is kind of a universal feature of operating systems, but it doesn't necessarily take the same flavor everywhere. So we're assuming that we're working on a Linux command line here, because the supercomputer that we're going to be working with later on is Linux. Specifically, it's Ubuntu. As I said earlier, things might change for CentOS or Debian or Fedora, whatever else you might be running. But here we're looking specifically at Ubuntu. Mac, the Mac operating system, OS X, is kind of like a Linux operating system. It's not exactly, but the differences are outside of the scope of this discussion. Basically, though, everything that we're running here can be run on the Mac command line, which is called terminal. The one exception is the slurm commands, and we'll talk about those when we get there. Windows is kind of the odd man out when it comes to standard command line behavior. Windows doesn't have a command line that has the same sorts of features. So for instance, ls doesn't work on, it doesn't work on the basic Windows command line. Windows actually has two, there's CMD and there's PowerShell. Both of them are very different than Linux, but they can be very useful. Often you won't find Windows command lines used in a research environment because tools are written with Linux in mind. But my job, which is more of like a systems administrator position, PowerShell's super useful. So the command line's a universal feature. The flavors vary, but all of them have a niche, and generally speaking, they're all useful. Question?
Is there a straightforward way to like get like a terminal on Windows that'll accept Linux flavored commands? Is there like a tool out there?
Yeah, so I don't have slides on this at the moment. There is something called, I think it's called Bash on Ubuntu on Windows, or the Windows Linux subsystem. You can Google either of those, and there actually is a Linux command line embedded in Windows now. I think you have to go through an enable developer mode or something similar to get that set up. But that is an option that's available. And there are also these things called virtual machines. So you can get, the program I use is VirtualBox from Oracle, and you can get an open source or a free piece of software that'll run virtual machines, and you can run a fully fledged Linux operating system from a virtual machine on Windows.
And is it noticeably slower or not really?
In my experience, I would say noticeable, but not like paralyzingly slow.
Yeah.
It's going to depend a lot on your hardware and everything, though.
Right.
So it's difficult to say.
Yeah, sure.
Okay. So let's talk a little bit about the components of the Linux command line. If we want to think about it, operating systems and programming environments have layers. So there's a very low-level layer in Linux called the kernel. And the kernel we're not going to really worry about because the kernel is for people who have PhDs in computer science and have been programming for 30 years. We're going to start at the level of the shell, which kind of sits on top of the kernel. And the shell in particular that we're talking about is going to be called bash. And bash is kind of an environment for interacting with the operating system, interacting with files that live on the operating system, and data that lives both on the operating system and in those files in the file system. There are other shells. There's Z shell, C shell, T shell, She sells seashells by the seashore. But bash is generally the default. And if you're not sure what you're using and you know you're on Linux, you can assume that you're working with bash, usually. Kind of sitting on top of bash, one layer out, there are a lot of really, really popular command line tools that you can use pretty much anywhere. They're available on pretty much any Linux command line. wget is used to pull data down from the internet. So if you need to gather data from an open source location or whatnot. grep is used kind of like Control F if you're familiar with that, or Command F if you're on Mac. It's used to find patterns of characters in text files and such. Sed and nano are two different tools that you can use to manipulate files and data. We'll talk a little bit more about those later on. And there's many, many, many more. Tree sounds like one of them. Top, I can go on and on. There's a ton. In addition to these universal command line tools, so they're kind of at the same layer of these tools, are programming languages. So you've probably heard of Python, R, MATLAB, Stata, Java, C, C++, PHP, JavaScript, I can go on. Programming languages are kind of like fully fledged computing environments of their own. They have their own sets of syntax, and they're used for, generally speaking, much more sophisticated and complex tasks than just bash. So you'll be probably, if you're doing research, you'll probably be running code in one or more of these languages. And you can access all of these programming languages and run scripts on them directly from the command line, also create scripts for them. Sort of. Then you have third-party software, which are usually utilities that are written in one of these programming languages or bash. And these add additional functionality that you don't necessarily see in the operating system or the shell itself, but also is rather difficult to create on your own in a programming language. The examples that are going to be meaningful to people depend a lot on your background. My particular background is kind of like bioinformatics. So if you imagine like raw genetic data, there's a tool that sequences that. It takes your fragments of data and it tells you where in the genome they are. It's called a sequence aligner called Top Hat. But again, there are a lot of different examples from pretty much every field that uses computing, which should be everyone by now. Okay, so how do we put this to work? We have all of these tools, you know, they're cool and all that, but you know, what are we gonna do with that? And so what we're gonna do here is gonna be kind of a toy example. We're gonna create a script that basically does Mad Libs, which if you're familiar with that, you give it a word and then you give it a word to replace, and then you look at the script and you look at the text after you've done that replacement, and usually it's funny. This is kind of a toy example, and I don't really want you to think of it as Mad Libs as such. The way I want you to think of it is we're manipulating and we're working with data, and this is the step where you're taking your raw data and you're getting it to a point where you can analyze it. So even though we're working with text data in this case, and even though we're doing kind of a toy example, the steps that you're going to be taking for any kind of research are almost always going to be exactly the same. So we're doing this toy example, but don't think of it as like the content of what we're doing, think of it as the steps in the process. So we're gonna have kind of a pre-processing, a data cleaning, if you will, layer. And then what we're gonna do, so that's gonna be done primarily in bash. Then what we're gonna do is we're gonna automate that data cleaning so that you can, somebody who doesn't have any knowledge of bash can run it. So if you have an undergraduate volunteer who's working with you, if you're a grad student say, and they don't have a programming background, we're gonna get this scripting, this data cleaning process automated so that they can run it without you having to teach them bash. And then what we're gonna do is we're gonna take the output of that pipeline and we're gonna run some analysis of it on a supercomputer. In this case, it's going to be a computing cluster called SSRDE that's hosted by the Social Sciences Division. But you can think of this sort of thing can be run on, you can do this on Amazon Web Service. If you have a server for your lab, it's going to be almost exactly the same process, so on and so forth. And so SSRDE works on kind of a job submission format. Not all servers are like that, but that's what we're going to work on. And then we're going to do, again, it's kind of a toy analysis in Python, but I guarantee that if you're in a lab and you're working on a lab, there are scripts that are going to be exactly, or that are going to do different things, and the process for calling those scripts is going to be exactly the same as it is here. So even if the content doesn't catch your mind immediately, think of the process and think of what we're doing and how the steps fit together, and you should be able to bring it back and put it to work in your lab without too much difficulty. So question that's probably coming to your mind, what do I do if I don't know how to do something on this process? If you don't remember anything else from this presentation, please remember this slide. I call it the central dogma of computing, if you will. Every problem that you have ever had, with some very, 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 very rare exceptions, has been experienced by somebody else. Not only has somebody else run into the same problem that you've had, they have also solved that problem and they've put the solution online. Think about what that means for a second. That means any problem that you'll have, again with very, very rare exceptions, any problem that you've had, the solution is already out there. The problem is already solved somewhere. All you have to do is find it. Even if you don't know how to program at all you have to do is find how somebody else has done it, and you can put that solution to work for you. What that means is Google Foo is kind of the silver bullet of computing. Obviously silver bullets aren't actually a thing, there are exceptions, but knowing how to Google and knowing how to find information is about as close as it gets. So we're going to be doing a hands-on portion of the presentation in a few moments, and the primary goal of that hands-on presentation, or that hands-on portion, is going to be to develop your instincts for Googling and for finding the solution to problems that you're not necessarily already in possession of the knowledge of how to solve. Now, if you're in part of the social sciences division and you run into a problem that your Googling isn't able to solve, you can contact SSCF. We're not programmers necessarily, and we're not scientists, so we can't really debug your code for you, and we can't really modify your experiment design. But what we can do is we can point you in the right direction. So if you need help with finding resources for natural language processing, let's say, we can't necessarily write natural language processing code for you, but we can show you where good free online classes, you know, MOOCs, Coursera sort of thing are, or we can show you where tutorials have been written with code examples, and we can kind of point you in the right direction to help you self-teach. Our email address, if you aren't already in contact with somebody from SSCF regularly, you can reach us at sscfhelp@ucsd.edu, and someone will be more than happy to help you get this sort of thing figured out. All right, so we're going to go into the deep end. So what I'm going to do is I'm going to give you a list of things that I would like you to do. And basically, I'm just going to try to have you do them on your own. I'm, of course, here to answer questions, or if you get stuck and you can't figure it out. But the first thing that I'd like you to do is to try to connect to SSRDE. The one hint I'm going to give you is it's a Linux server. And knowing that, you should have enough information to be able to figure out the process on your own. And again, the idea is to kind of help you develop your ability to work independently, rather than just feeding you code for you to copy and paste. So I'm going to give it about 5 minutes, and again, I'm here for questions if you need, but I'm going to kind of let people hopefully play around with it a little bit on their own, and hopefully figure out what's going on. If you're here via video, if you're watching the video, of course what you can do if you need more time is you can pause the video, and then of course if you don't need as much time, you can skip forward a little bit, and you'll again get to the end, and we'll proceed from there. Okay, so I'll give you about 5 minutes, and go back.
Michael, question.
Yes.
So not everyone here will have access to the cluster, right? Because not everyone is.
Oh yeah, sorry.
TSS.
So if you're not a member of the social sciences division, you will not be able to access the cluster. If possible, so for the folks here who aren't in that situation, if you could pair up with somebody who is from the social sciences division. I'm sorry, I didn't get your name.
I'm Stephanie.
Stephanie. Unfortunately, I think you're the only person who doesn't have access. So you should be able to catch on with anybody.
Yeah.
Dave, if you log into it before you go.
And then, so if you're watching the
Maybe you
video,
can just sit there and you see our.
if you're watching the video and you're not able to connect to SSRDE,
Let's do it on.
Amazon Web Service is one alternative. And there's a free version of Amazon Web Service that you can use to SSH into. There are tutorials for that online, and if you're a member of the social sciences and want to get a hold of us, we can help you with that. And then you can run everything except the last step that we're doing on Amazon Web Service. and I will
Right, okay.
give modifications to let you run that part as well. Okay.
Oh, yeah, you
Um,
can do all that stuff. Sorry about that.
So I have 1226, so we'll say a 1230, 1231. We'll
So what we
reconvene.
want to do is SSH space and SSCF Dave hyphen at ssrde.ucsd.edu.
Actually, if you guys have it and you want to let me know that you've got it, so I don't need to
Enter.
spend the full 5 minutes because we're probably going to be a little crunched for time.
So you'll get this the first time you sign in. So just say yes to accept the key. Yep. Or yes. I thought I would like let me go on this. Cool. So yeah, next time you sign in, you won't get that fingerprint notification. So this will be your AD or your SSCF Dave password. So do you have a cluster down at the library?
I'm part of the cluster, but I have the San Diego supercomputer
Oh, sweet.
if needed. Yeah.
Nice. Okay. Yeah. We're in. So you'll get this welcome screen every time you sign in.
Okay, so you guys are in.
Yeah. We're in.
You're having all right. Did you ever get Putty installed?
Yeah, I got that.
So for users outside of our division,
Okay. So-
sometimes our labs will have like collaborators.
Minor additional
There's
note for
a
Windows.
SSRE group
If you
that you can add them to, which will
if you
grant them
just-
access to
so-
the cluster.
the process
this is
for
for
users
users
is a little bit different on Mac.
Yeah.
Linux
Okay.
versus on
So this is for
Windows.
users
But if you just
outside of social sciences.
when you're looking, if you just add Windows into your
So
search
is the
searches,
SSCF for anyone in social sciences, or is it a separate subset that people have to?
if you add the word Windows into your searches, that'll usually
Cool.
give you
Yeah,
those
which is
specific
for
instructions.
business like a staff, business office staff,
Okay.
Need any other
faculty,
info?
research labs, and grad students, and some undergrad.
Okay, so if I get questions from students that are asking about resources, I can with a clean conscience grab them.
Yeah, yeah, you can.
SSCF. Okay.
Yeah, you can direct
Good
them
to know.
us. Yeah, for sure. And they should already have access to it. They probably just don't know. But yeah, you can.
Yeah. Okay, that's great. Because yeah, they're I had a couple questions and they're getting outside the limits of their laptops, and I
Okay.
can't necessarily get them onto SDSC.
Yeah.
Is it set up so that everyone has equal access, or do you have like a node specifically for like first come first serve?
Yeah. So there's how many nodes? 4 different nodes currently? 5? One's
No,
at
there's
one-
like 15.
Oh wow.
So what there are 5 different queues. So
Mhm.
there's like a general queue where if you don't
Or queues,
specify
yeah.
it gets dumped into one queue with like 10 nodes, I think. And then if you need specifically single thread CPU performance, we have a node or a queue we call fast queue. If you need a lot of RAM, we have one called Big Mem. And we have a couple different GPU queues.
Okay.
And it's if you're familiar with Slurm, I think it's pretty much out of the box Slurm.
Okay.
So it's you submit a job, it gets sent to a first come first serve, it gets sent to a node. If you don't specify, it just goes into one of the general nodes, and then it runs either until you complete or until there's until you hit like an upper time limit. I think it's 30 days for the general queues, and for the ones like the GPU, I think it's like 8 hours.
Okay. Yeah.
So that's generally how it works.
And if they want more compute time, then they can send us an email and then we can queue it up to give them
Okay.
additional time.
Time.
But this is meant more for like small to medium, large, small kind of compute jobs. And if it's like kind of to test your code, and then if they find that it's something that's working for them, they want to run on something big, then we also have some pull at the supercomputer where we can
So you're in the
offer
nodes.
our
Right.
students access.
Okay. That's
hours
great
of
to
this.
know.
Or
Thanks.
queues.
Okay. Does anybody anybody in the audience want specifically more time? Obviously, if you're watching the video, you can just pause it and keep going. Or do you want to reconvene and see what the answer is?
I think we can see what the answer is.
Okay. So the solution for this, so the Google search that you can do to find this is connect to Linux server. So if you Google connect to Linux server, this will be the first response you get. If you're on Windows and you do a Google search for connect to Linux server Windows or connect to Linux server PuTTY, the process is a little bit different. So for Mac and Linux, what you do is you type in SSH, and then in this case, since it's a UCSD cluster, or it's a UCSD server, you're going to enter your UCSD username, and then at ssrd.ucsd.edu. It's generally speaking going to be the same. So if you want to connect to a server called example, hosted at example.com, it'll be your username on that server, and then it'll be at example.example.com. Kind of a confusing, sorry about that. For PuTTY, what you're going to do instead of this is you're just going to open up PuTTY, and there will be a field that says either hostname or IP address. All you're going to do is you're going to type in ssrd.ucsd.edu there, and then I think the option is connect. You hit connect, and then it'll ask you for your username and password, and you log into it exactly the same way you log into the UCSD VPN or the internet. So that's the process behind connecting to servers, and hopefully, if you're in social sciences, that gets you in, and then we can start playing around. So the next thing that I want you to do is create a directory called madlibs and change into it. I don't think this is going to require a full 5 minutes, so I have 12:32 now, and I'm thinking we can reconvene at 12:35. But play around with it a little bit, and if you do get this part done, maybe explore the file structure a little bit, and then we'll reconvene in a few minutes and we'll continue. And it turns out that the name of the file doesn't really matter. I just gave it a name. I just said use madlibs for uniformity, but as long as you remember the name of the directory that you create, you can call it anything.
If you hit the ls command, you'll see the file. And if you do pwd, it tells you what directory you're in. So you're in your home directory, the SSCF. Michael, there's also that mailing list on the SSRDE login page. People can sign up to if they want to receive announcements.
Yeah, gotcha. I think that mostly ends up being for outages, but maybe we should be a little more
We'll start
active on
using
that.
it more, yeah.
Yeah, we can like point people towards good tutorials for like machine learning or whatever. That'd be pretty cool. Okay, does anybody in particular want more time, or should we reconvene? Cool. Okay. So this should have been a little bit simpler of a solution. So as we discussed earlier, you just run the mkdir command and then you cd into it. If you're ever not sure your location, you'll notice as you're moving around the command line that the little bit of text before you can put in commands changes, and it generally keeps track of your file path to a certain extent. But you can always run the command pwd, and that will tell you currently where you are on the server. So that's a useful command. And then remember, of course, if you're looking for subfolders or files in a folder, you can run ls. And then if you need to go upwards instead of downwards down the tree, you can run cd .. and that'll go up one level. And you can chain that too, so you can do .. if you want to go up 2 levels, so on and so forth. Okay, now this might be a little bit trickier, but what I want you to do now is to find a data source. And again, I love Tale of Two Cities, probably my favorite book. So I'm going to tell you to go out and get a copy of it. The hint I'm going to give you, you don't have to own it or pay for it, and you don't need a physical copy. This is something that you can get from your computer. So I have 12:35. If we could reconvene at 12:40, and if you need any help on this, let me know. And remember, again, the overall point of this isn't so much to do the steps as we're doing them. The idea is to get an intuition for broadly finding data, or broadly finding answers to technical questions, and more specifically in this case, like learning how to find sources of data that you can use for your research and that sort of thing. So if you get stumped on particularly finding this book, you know, maybe if you're doing EEG research, maybe see if you can find an open source type of EEG data, you know, so on and so forth. Also, one other thing, doing this specifically on SSRDE, I was kind of cruel to ask of it, and we'll talk about why in a little bit.
So you want us to find that text and then copy it into a text file or we just looking for the text?
So once you've found the text, there is a command that you can run that will grab it and pull it down without you having to copy and paste. You can copy and paste, there's not really any reason that you can't, but especially for big text files like this, it's kind of a pain. And then you also run into the issue, if you're on Windows and you try copying into text from Windows to Linux, you'll find that the encoding for things like spaces doesn't always work correctly, and so you can mess up the formatting. Because of that, I strongly recommend trying to find a Linux command that'll do this.
So is this text file, it's not on the cluster, right? We're looking for it. Just
No, yeah,
online.
it's out in the world,
Okay.
and it is possible to find and use it without paying for it.
Search how to download it with the wget command. Am I on the right track here?
Give it a shot, see what happens. So this step especially, I think, is really important, so if we want to spend more time on it, we can. We got about a minute to go anyway, but I want to make sure everyone gets this a shot, gives this a shot. Is anyone opposed? I think we'll make it in right about 1, but if we go about 10 minutes over to give you some extra time, is anyone seriously opposed to that? We have them until 1:30. Oh, you got it, okay.
Before one?
At the end of it, we're going to get into stuff that's more specific to SSRDE. So the end is probably the least generally applicable part of it.
Cool.
So.
Just sorry to sneak
No,
in.
not at all. Anyone running into any issues?
Not really sure you need that array in there. I think I'd the simplest form is
So-
wget
Actually, like I said, I was
And
looking
then
at this.
URL.
That's
However, it says
expected.
I'm connecting to
If you want to, while everyone else is
Doesn't
catching
seem
up,
like I'm
if you
getting
want to look
anywhere.
into why, that's it. That's something. Oh, that's as far as.
What does it say the
Okay.
dash zero is for?
So you guys know. So I've seen a couple people in the audience get to it. If you need some more time on the video, just feel free to pause it, of course. A couple people have gotten here. It turns out you can't actually do this on SSRDE. Like I said, I was cruel. This is why I was cruel. Anyone in the audience know why, by chance? Joe, you might be the only one.
Firewall?
Yeah, exactly. Well, I think it is the
Security.
firewall. So the reason that this isn't doable, so one part of this is wget, and learning wget is good. The other part of this is finding open sources of data. One of the ones I really like is it's called Project Gutenberg. So Project Gutenberg has like text and EPUB files of lots of what do they call them?
Out of
Open domain.
copyright texts.
Out of copyright text, yeah, that's good. This is the URL to get a free version of A Tale of Two Cities. This is a plain text version. They also have like EPUB and whatnot. So that's really cool. What you'll find though when you run this command on SSRDE is that you can't actually establish that network connection. And the reason for that is that SSRDE is in a private IP space. I would suspect that this is really common for research servers and whatnot as a security measure. Excuse me. And if you want to do a little bit more reading on that, what you need to get around it is called a proxy. So you can look into proxying on Linux to see if there's a way to actually wget data if you're on a privately IP'd computer. So let's try again. Since this is an issue, on my own, I set up proxying and I got a copy of that file. So this is also a common thing in research. Usually you'll find that if there's data sets that you're using a lot, there's already a public copy on your computer. So let's see if you can go and grab a copy of that and get it in your directory to work with. The hint I've given is a potential good point for starting to find that text. And then what you're going to do is you're going to move around the file system to get to that point, and then bring a copy. Please don't move the file and just copy it over to your home directory or to that MATLABS directory. Sorry, I forgot about that. And then we can work on it from there. So I'll give you, it's 12:44 right now. We'll go to 48:49, and then we'll reconvene. Thanks for coming. Feel free to email us if you have any questions.
Thank you.
Are you sure that file's there? Oh, I tried cat.
It's case sensitive.
Yeah.
I don't think the Windows file system is what Linux is. Windows can also use spaces, but Linux doesn't like spaces. So one more hint, the Linux file system is case sensitive. I don't think Windows is, and I know Windows allows you to put spaces in your file names, whereas Linux doesn't. But bear in mind that the Linux file system is case sensitive. Question?
You can't put spaces in Linux file names?
I don't think you can. I think if you double quote them.
Yeah.
Oh, okay, okay.
Yeah.
So out of the box, you can't put spaces in file names.
Yes.
If you're working with file paths and there's a space in the file name, you can double quote it. But that's outside of the scope of the specification. Sorry,
Yeah.
it's not accurate to say that Linux doesn't work with spaces. Sorry about that. Thanks for the correction. Appreciate it.
You can have spaces in your file name. You just shouldn't, because you're making problems for yourself. later.
Yeah, it's not pretty.
It's not good.
What's that text file there? .txt.
How's it going? Actually, this is a little bit like looking in the answer book ahead of the time. But if you get to the point where you've got the copy of that text file moved over, then there are some other files in that directory. I'm not sure we're gonna have time to create them ourselves. So if you move them over, if you move them over, what we can do is we can just look at them rather than recreating them ourselves for the later steps, and that might save some time. Give it one more minute. Does anyone specifically want more time to work on it, or is it all right if we reconvene? Good to go. Is it good to go?
It should. I had to get back to this folder. The CD. I'll take it. You might already have the path. We need the up arrow.
If you guys want to keep working while I'm talking, that's totally
Yeah, go
fine.
for it. You can.
Okay.
Fine.
So the solution in this case, you can CD over to this directory, and then you can copy files back. But the copy command, which is the command you're going to want to use, CP, will allow you to put a whole path in there. So you can go and you can get a file without having to actually change directories. So in this case, this is where the file was stored, like I said here. The file in particular we're going to want is A Tale of Two Cities. What you can also do here is you can also use the star. It's Shift 8. Wildcard is what it's called. And a wildcard in Linux means anything. So when you run CP, give it the path to the directory where the data's stored, and then you have a wildcard here instead of that. It gets everything in here, and it copies it over to the location. The period in Linux means the current directory that you're in. So if you run if you run this command from madlibs, it's going to go and it's going to grab the A Tale of Two Cities text file and it's going to put it in your madlibs directory. If you run this command and you replace atot.txt with just a star, it'll get everything in this directory and then it'll bring it back over there. Okay. So the next step, what you're going to want to do is you're going to want to madlibsify the text. It's just, in this case, we just want to run one find and replace. So you're going to want to look for the Linux command that will allow you to find and replace text, and you're going to want to run it once on this file. As a challenge, rather than overwriting the file, rather than overwriting the text file that you're working with, see if you can move it to another file. See if you can move the output to another file, so that you don't modify the only copy of the text that you have and then have to recopy it. So I have 1252, so at about 57, I'm thinking we'll reconvene on this.
It's there, copy it over. Do CD, take you back to your home directory, and then do ls/madlibs. You can do.
There we go. So now that you have that text file of A Tale of Two Cities, what you're going to want to do is you're going to want to replace one of the words in A Tale of Two Cities with another. So like, replace the with this, or replace tail with head. Something along those lines. And then if you can, rather than modifying the file directly, run the modification and then save the output to another text file. Glad we booked for 9:30. Or 1:30. So,
I think it was 150.
oh, okay. 1:15 should be fine. We're getting there.
So you said this with that, we can just pick any word we want to replace?
Yeah. Any two words.
All right.
Obviously, I'm going to pick acceptable words. I'm not going to do anything obscene, but
Yeah.
there's nothing stopping you guys because I won't tell. Any hiccups or anything? Good to go.
Yeah.
Okay.
I think
All right, so let's just reconvene. Obviously, if you're on video and you need more time, pause the video. And then if you want, we can continue working. I think I may switch from hands off, switch from hands on, just to showing you guys how it works, to save some time. But we'll see how it goes. So the solution in this case, sorry, the name of the text file is a little bit off. I forgot I renamed it. So, and again, in this case, you're going to want to use the command sed, which we showed a little bit earlier. And something a little new that we're introducing here is the idea of flags. So this -e, what it's saying is, I'm sorry, to be honest, I forgot what it says. I forgot to read up and remind myself what it says. But anyway, so these flags allow you to do different things and to modify your commands a little bit. So we might imagine, I think there's an I flag that sed has, and that I command is in place. Actually, no, I'm sorry. Anyway, but essentially, so imagine, so sed just finds and replaces files, or finds and replaces words and strings, or strings of characters, if you will. You can also point it at text files, which again are just stored sequences of characters. And sometimes we might want it to, sometimes we might want to modify the text file in place. Sometimes we might want to change the output, sort of thing. So flags are there as a way of modifying the way the command runs slightly to give you some more flexibility. There's a command in Linux that you can run called man. So in this case, it would be man space sed, and that will give you all of the flags and what each of the flags do for sed. And then, so in this case, the S I'm pretty sure is string matching, and then this is the word that we're finding, this is the word that we're replacing, and the G means global, it's everywhere. I think if you don't include the G, you still need the slash, and what it'll do is it'll just replace the first instance. And then this is telling it to look at a text file rather than just a string of characters. And then if you want to run this command and then take the output of it and stick it somewhere that's not the original file, you do this little caret here, and then you just give it the name of a new file, and it'll create a new file and it'll dump all the output there.
Question, is there a space next to that caret there, or is it?
It's
Is there a, yeah. is there-
txt space sideways caret space ATOT.
Okay.
Yeah. That's another thing you'll find out about computers. They're very picky about syntax, and so you'll want to be careful that you're typing things as you expect them to be typed. Okay, so now we've got this modified text file, and then there's a couple. You can run less, more, head, tail, or nano, and all of these will show you the text. I'd recommend nano because nano lets you scroll through it. So if you want to run nano and then the name of the modified file, if that's the original file, then that's fine. You can see that you can go through and you can make sure that your changes were actually made. So if you were to look through my ATOT.modified, you'll see it would say it was the tremendousest of times, sort of thing. Okay, so the next step is to run a is to automate it so that somebody who doesn't know any bash can modify it. And I'm sorry, I should have warned the video folks, if you want to go back so that you hide the solution, you might. There is bash file called madlib.sh if you guys copied everything over already. And if you want to, rather than writing it, if you want to just read it, you can do nano-madlib.sh. And then for the folks at home, if you don't want to see what it does, if you want to write it yourself, pause right now. But what I'm going to do, just in the interest of time, is run through it a little bit. I have to SSH back in. So I'm gonna nano so another example of flags. This -C for nano gives you line counts, so you know you're on line 1, line 2, whatever. So that's an example of a useful flag for nano.
-C?
Yes.
Nice.
And then, so what we're doing here, so this is that automation script. So I'm just saying this echo, if you know any programming languages, echo is the equivalent of print in Python. I think it's DISP in MATLAB. In Java, it's system.out.println, so on and so forth. So I'm just echo, and then I'm giving the instruction of what to do. That read command is how you read in user input in bash. So I'm reading in a word that's going to be replaced, and then I'm reading in a word that's going to replace that word, and then I'm running basically that same command that we read to do the find and replace. One thing you'll notice, this $1. So there's this, when you're running scripts, there are these ideas of arguments. $1 refers to the first argument. And what that means is when we run this script, there's going to be something that we're putting after, and then the bash script is going to know to look at that. It's that $1 means that it's capturing whatever the bash script is running. In this case, it's going to be the file that we're running the find and replace on. And then it's going to redirect that output again to, I'm putting a prefix on it so that we know we've modified it. And then, so it's going to have this prefix and then the name of the original file. And then this is just a permissions thing. You can ignore that. Permissions are kind of outside the scope of this. So to run a bash script, you do // and then the name of the bash script. So in this case, we're going to do /madlib.sh, and then we're going to give it the name of that text file. So see how, so the name of the script is the 0th argument. Generally, that's not used. But then this name of the text file is the first argument. And so again, that $1 in the bash script is how we're capturing this. So when the script runs and you call it with this argument, anywhere that $1 shows up, it's going to show this. And so now when we run it like this, the script knows to modify this particular file, and then word to replace. I'm going to do tail with head. And then, so if we do a nano on MD, the modified version. So notice it doesn't do the first one because it's case specific. So since I did capital T and then lowercase everything else, it's not going to grab that first one. So actually, that was a bad example. Sorry. Let's do best with happiest. This will give a much better example. So see here, we can see that modification. And now that we've got that, let's look at a, so we talked a little bit, SSRD is a supercomputer center, or it's a supercomputer in that it's a cluster. And what that means is that SSRDE actually represents a number of different computers, and all of those computers are tied together such that you can run commands on them. And then the cluster software, in this case it's Slurm, if you want to look it up, is able to pick out a computer that's free, if there are any free computers, and then it'll submit your job to that computer, and then you have a specialized computer running Slurm all on your own. So we have here, you'll notice there's a script called frequency.py. We can check that out. And this, all this does is it counts the frequency of every word in the script file. And don't necessarily think of it like that though. Think of it like this is where you're running your actual scientific analysis, basically. This is where you're gonna run your stats on it. And then, I'm not gonna go through all this because Python's kind of outside the scope of this course. But basically you can see it's reading in the modified file. It's replacing that /n as the new line character. So instead of, so when you hit enter, it puts in the /n, and it's just stripping all of those out to make the words actual words instead of random word /n. And then it's stripping out punctuation. It's splitting into each word, and then for each word, it's counting the frequencies, and then we're printing out the frequencies. So to run this, you need a bash script to tell the node that your job is assigned to what to do. So that bash script here, it's just calling Python on the first argument that we give it. And so to actually submit that as a job, and if you have all of the files in your home directory, you can do that. To actually submit the job, you run this command called sbatch. You can Google that to find more information. And then you run your run job script, which again you should also have, and then you give it the name of you give it the name of the file that you want Python to run. So what's going to happen, actually before we do that, we'll show you what we mean by cluster. So if I run sinfo, you can see there are there's a bunch of different information. Each of these partitions, again, you can think of it like a queue. It's a set of nodes that are available for you to use, And we'll see this general queue has 10 nodes that are idle. So when we run when we submit a Slurm job, if we don't tell it to go to one of these other queues, it will it'll go to this and it'll assign one of these 10 computers that job, and then it'll run it on those computers. If you are a member of the Social Sciences Division, you should have an email from Tom Guptill and talking about SSRDE, and he has some slides specifically for what each of these queues do, and specifically how to submit Slurm jobs. So if we go and we do sbatch without specifying a queue, we do our run job shell script, and then our Python file. It's going to perform that analysis. And then so it says submitted batch to job. It says submitted batch job. So that means that it's received a job, it's given the job a number, and it's stuck it on a computer. So now it's going to run on that computer. I can walk away, and then when it's done, it will spit out something like this, and that'll show us the output of our file. I've already run this job. I think it takes about maybe 5 minutes to run. So rather than sit and wait for it, I'll show you what the output is like. 6. This is the one. So this is again just the frequency of every word. And this isn't super interesting. Obviously, the is going to be the most frequent word. So don't think of it like, please, if your research is anything like this, please don't use this code. This code is not research ready. The experiment design is not research ready. Any of that. But think of it instead, so that frequency.py script, instead of thinking of it as doing this, think of it as that's where you put your code. That's where you put your research, the research the analysis that you're running. And think of this as the output. So imagine that whatever you expect your output to look like, this is where it comes in. So I know that was kind of a whirlwind tour. I hope it was fairly coherent. And just as a recap, what we've done, if you want to go back and watch the video again, what we've done is we've kind of practiced working through the command line. We've kind of practiced finding data, interacting with the server that you're going to be processing your data on, developing a pre-processing pipeline, and then running the analysis on a batch computing service, in this case Slurm. Does anyone in the audience have any questions?
How do you run usually a code?
Sorry, a second.
I want to run Julia.
So I know Julia's installed. I don't know exactly how to run it offhand, but this is a great, which you're in the economics department again, right? So if you could email us at sscf-econ@ucsd.edu, I'm pretty sure it's on there. I'll just need some time to find the command, and I can reply to you and I can give you the command to run Julia code. And then anybody who's watching and may want something like, so we have Julia on there now. If you want, I don't think we have Scala. If you want Scala, you can just submit an email to us, and then if it's open source, if it's not licensed, usually we can get it installed and ready for you in a couple days. Anybody have any other questions?
So what packages are on the cluster currently?
That's really hard to say. So again, like with SED and Nano and all that, there's a bunch of others in Linux like awk. So trying to give any sort of comprehensive list of what's on there, it's going to be either thousands of items long or it's just not going to be meaningful. Off the top of my head, resources for programmers, I know we have Python, we have R, we have MATLAB, we have Java, Fortran, C, C++, and Julia. So just as a start, what your code is run on, what your code is run on is all of those. If you want something else, send us an email and let us know, hey, I need to run code in this language. And if we can't get it on SSRDE, odds are that we have another more specialized computing resource that you can use still. Okay, I think we'll go ahead and cut it off for there now. I will repeat again, sscfhelp@ucsd.edu if you're part of the social sciences division and you have any more sophisticated questions, if you need any more help with advanced stuff on this. If you would like a more directed focus type of this presentation, so for instance, if you want me to go through an example of working with EEG data or something, I think that may be doable. So just shoot us an email and request, and if that's something that I can do, then I may be available to give more targeted presentations as well. Thanks so much.